Hello everyone, today I'm going to talk about MQTT protocol. So what is MQTT? MQTT stands for the Message Queue Telemetry Transport. It is a protocol based on TCP/IP. And it is a lightweighted publish-subscribe messaging protocol, which we'll mention later what is publish-subscribe messaging, designed for low bandwidth, high latency, and unreliable networks. It is now widely used for IoT applications that require low bandwidth, low power consumption, high reliability, and scalability. So in case you don't know what IoT is, it means all devices that connect to internet to simplify, like your phones, laptops, sensors, smartwatches, etc. So the history of it, in 1999, oil and gas pipeline talks to the SCADA system. The SCADA system, you can think of like we have a software that can monitor the behavior of the pipeline. So how are we going to communicate with them through some kind of mechanism? The one issue is that the pipelines are usually located in low bandwidth areas and their battery power is low. So people have come up with one way to use satellite to connect them. However, this approach is very expensive because you use satellite, so it's very expensive. You send a message to satellite sends to the pipeline, something that's really expensive. Even nowadays, it's still very expensive compared to the internet. There people also come with another way, which is use some disparate their own protocols for their own system. So they'll use their own protocols for their own system. However, there are some issues because of the protocols are so many protocols, and they cannot communicate across different systems because of they use different protocols. So one way to solve it is the MQTT protocol, which is invented by Andy Standard-Clark and Arlen Nipper in 1999 to solve this problem. And it also suits the engineers needed for IoT devices because of its bandwidth efficient, lightweighted, and little battery power consumption. And since in 2008, the open source broker, which is a server, Mosquito released, and it boosts the adoption dramatically. And it also became a industry standard nowadays. And a lot of companies, Amazon, Microsoft, use MQTT as their core protocol. We can see it is widely used for IoT platforms nowadays. And how does it work? Basically, it has a publish-subscribe mode, which is quite different from traditional end-to-end communication. And it also has a MQTT broker server to direct the communications. So here's an example. Imagine you have a client A1 who records the temperature and sends to the server. You'll publish the information to the server, and the server will store information. And then the next client will subscribe to the server and ask for the temperature. So server will send publish to the client, including the temperature of A1 if it wants. We have multiple clients, multiple subscribers, and multiple publishers, and they will publish and subscribe their own information. Okay, so MQTT clients are split into two groups: a sender, a publisher, and a subscriber. So unlike the traditional communication, the publisher and subscriber are never in direct connection. Okay, MQTT broker will do the communication between them. And the connection is kept alive once the connection is built. Like the subscriber will subscribe to the channel as long as it wants. Here we'll talk about some comparison between MQTT protocol and HTTP protocol. For the connection part, the MQTT will keep the connection open as long as possible. But for HTTP, it will open and close a new connection for every packet you want to send. So HTTP actually wastes a lot of power to just resending the header every time. So that's why MQTT is suitable for the low power device and the device with low bandwidth. And for data packet, MQTT also only has like 2 bytes for the header, and no encoding is needed. But for HTTP, the packet is usually more than 8 bytes, and we need encoding. And encoding actually takes the CPU power. So that's why MQTT is suitable for those devices with low CPU power. And for the purpose part, the MQTT will fit more for scenarios where we need frequent data exchange, device with low bandwidth and processor power, and the cost for communication is high, while the HTTP is the opposite of MQTT, basically. And for There are also some disadvantages of MQTT. For one, MQTT does not support streaming of any kind. So you cannot watch video or listen to audio using MQTT. And it uses TCP protocol, which still requires more process power and more money to do so. And the broker is centralized. The centralized broker will potentially limit the scalability because each device will take some overhead. And it does not support advanced features such as flow control. And also the clients, to communicate using MQTT, the clients must also support TCP and IP. And then since there's no encryption in the protocol itself, no encoding in the protocol, we might have some security issues. And it also has some limited features and a standardization because it is a lightweighted protocol. Here are the references, and thank you a lot for your listening.